In this video, I'm going to show you how to make a figure for the introduction of your manuscript or of your ESA presentation. And so for this example, let's say that you are interested in how the body size of ants changes on a tree, whether the body sizes of ants tend to be larger towards the canopy or towards the base of the trunk of the tree, or whether there's no difference. And let's say for the sake of this example that there are 9 studies that had previously been done on this topic, but your study might be the most comprehensive of these, or your study might be conducted in a new habitat where this question hasn't been asked previously. So one thing that you could do would be to make a table like you see here. Here in this table, we only have 2 rows for 2 previous studies. You would want to do 9 in this case if there have been 9 previous studies. But you can see here we have all of this different information about the study, as well as the result and what the p-value was. And so if you have a table like this with 9 rows, there's a lot of information in there, and it's going to be really difficult for your audience to pick out patterns. And that's going to be even more so the case if your manuscript only has these previous studies described in text as opposed to in a table. And so as an alternative to writing a paragraph or two about this or presenting this information only in a table, we can also make a figure. And so we can do that. We can start off by making a figure. Let's just draw a little tree here. As you can see, I just drew this tree in like 30 seconds in Adobe Illustrator. And then next to the tree, we can have arrows. And each of these arrows is going to represent one of those 9 previous studies. And the arrow is going to point in the direction of larger body size. So an arrow that's pointing up is going to indicate that ants tend to be larger at the top of the tree. So this is what we started off with, and then when we add those arrows, they look like this. So in this case, 1/3 of the previous studies found larger ants towards the top of the tree, 1/3 of the previous studies found no difference in body size, no significant difference perhaps, and then 1/3 of the studies found larger ants towards the bottom of the tree. So now we've got our arrows, we've already summarized some of the information. But what we can also do is we can change the width of the arrow to indicate how many ants were examined in each study. So here, this is what we had before. Each of these arrows are of the same width. And what we can do now is we can change the width of those arrows, and we can see here in the middle of the figure that the studies where they found no significant result also were some of the studies that looked at some of the fewest ants. And the studies that looked at the most ants tended to find that the larger ants were towards the base of the tree trunk. And so what we can do in addition to that is we can change the color of these arrows to indicate how significant the p-value was. So before, all of these arrows were the same color, and now we can color them in with darker green, meaning more significant p-values, and white, meaning non-significant p-values. And this is what we get when we do that. And so we can see that, for example, towards the right, the arrow with the least significant p-value, the lightest arrow, the least green arrow, is also the thinnest arrow of these 3. And so we can start to get a sense of how the sample size in these studies is also influencing the significance of the results. And then one last thing we can do is we can arrange the arrows by latitude, because right now the arrows are arranged according to whether they found the largest ants towards the top of the tree, towards the bottom of the tree, or neither. But the direction in which those arrows is pointing already communicates that information. So we can rearrange these arrows without losing information that we were communicating previously. So this is what the figure looked like before, and then if we rearrange these arrows according to latitude, we get something like this. And then all of a sudden we see that there's also this geographic signal. So the larger bodied ants tend to occur towards the canopy in the more tropical habitats that have been studied. And then once we get into these more temperate habitats, the larger ants tend to occur towards the bottoms of the trees. And so this figure doesn't have any y-axis at all. This is a lot like the flatten the curve COVID figure in that it's a figure that isn't communicating a ton of data, but it tells a story and it can help get your audience interested in your project, and it can help kind of engage them and it'll capture their attention.